Also, I wanted to mention before the video begins that I'm very grateful for having 24 subscribers. Thank you for all those who have subscribed to me. Hi everyone. In this video, I'm going to talk about gravitational waves. What is a gravitational wave? A gravitational wave is an invisible yet incredibly fast ripple in the space. Travels at a speed of light around 300,000 kilometers per second. These waves squeeze and stretch anything in their path as they pass by. Scientists have known about it more than 100 years ago thanks to the genius Albert Einstein. It is his idea about gravity and space. He predicted that something special happens when two bodies, such as planets or stars, orbit each other. He believed that this kind of movement could cause ripples in space. These ripples would spread out like the ripples in a pond when a stone is tossed in. Scientists call these ripples of space as gravitational waves. What causes gravitational waves? The most powerful gravitational waves are created when objects move at very high speed. Some examples of events that could cause gravitational waves are when a star explodes asymmetrically, it's called supernova, or when two big stars orbit each other, or when two black holes orbit each other and finally merge. Or the last one is when two neutron stars collide. But these type of objects that create gravitational waves are far and away. And sometimes these events only cause small, weak gravitational waves. The waves are then very weak by the time they reach Earth. This makes gravitational waves hard to detect. We have two observatories with two long arms and that are each more than 4 kilometers long to detect gravitational waves. How are gravitational waves detected then? When a gravitational wave passes by Earth, it squeezes and stretches the space. LIGO can detect the squeezing and stretching. Each LIGO observatory has two long arms that are each more than 4 kilometers long. For example, when light comes through laser beam splits into two parts. Normally, the lengths of the two beams are the same. This will change with gravitational waves. It is like one arm of the light beam becomes longer while the other becomes shorter. This is what we call stretch and squeeze. When the length of the light changes ever so slightly and the sensitive appearances of LIGO will pick it up. A passing gravitational wave causes the length of the arms to change slightly. The observatory uses lasers, mirrors, and extremely sensitive instruments to detect these tiny changes. The ultra-sensitive observatory will pick any small distortion in space-time, narrower than 1/1,000,000th of a diameter of an atom. Listening to these faintest whispers of our own universe. Isn't it amazing? Einstein was right. The first detection of gravitational was very important event in science. Before this, just about everything we knew about the universe came from studying waves of light. Now we have a new way to learn about the universe by studying waves of gravity. Gravitational waves will help us learn many new things about our universe. We may also learn more about gravity itself. The first form of detecting gravitational ripples, supernova. A supernova is the explosion of a star. It is the largest explosion that takes place in space. Where do supernovae take place? Supernovas are often seen in other galaxies, but supernovas are difficult to see in our own Milky Way galaxy because dust blocks our view. In 1604, the great German scientist Johannes Kepler discovered the last observed supernova in the Milky Way galaxy. NASA's Chandra Observer Telescope discovered the remains of more recent supernova. It exploded in Milky Way more than 100 years ago. What causes a supernova? A supernova happens where there is a change in a core or center of a star. A change can occur in two different ways, with both resulting in a supernova. The first type of supernova happens in a binary star system. A binary star system has two stars that orbit each other at one point. One of the stars, carbon-oxygen white dwarf, steals matter from its companion star. Eventually, the white dwarf accumulates too much matter. Having too much matter causes the star to explode. It's like eating too much and then you explode, resulting in a supernova. The second type of supernova occurs at the end of a single star's lifetime. As the star runs out of nuclear fuel, some of its mass flows into its core. Eventually, the core becomes so heavy that it cannot withstand its own gravitational force. The core collapses, which results in the giant explosion of supernova. Just something I want to let you know. Our sun is a single star, but it does not have enough mass to become a supernova. The second form of collision that brings gravitational ripples is when two gigantic black holes collide. In 2015, in LIGO, they detected and transformed the message into sound, and it sounded like this. What happened? There were two black holes, unimaginable dense objects. They were getting close and close. Immense gravitational pull forces them closer and closer. Finally, they collided, and astronomers will not see a thing. From the name you know, the black holes emit no light. How can someone see when no telescope can detect? In 2015, LIGO picked up a faint whisper traveling towards the Earth over 1.4 billion light years. Two colliding stellar black holes spiraled around each other, dancing and creating ripples in the fabric of space-time. These ripples, known as gravitational waves, arrived at Earth on December 26th of 2015. From the waves, astronomers were able to detect so much accurate information such as the size of those two black holes, density, and direction from where the sound and the ripples came from. One of the black holes was 66 times the mass of our Sun, while the other was 85 times. As they spiral in towards each other at a rapid speed, the gravitational waves and ripples will signify and witness higher frequency. As the time goes on, the pitch would be even much higher. As they merge, they become a giant with a mass of over 140 times of our own Sun. Merging black holes create huge ripples, which can basically destroy any planets or even stars nearby. However, the inversion rules apply. Farther the collision, the ripple effect will be less effective to Earth. So we are good for now. Collision of two neutron stars. This is one of the violent events in nature. When two neutron stars collide, a burst of light will show up for a fraction of seconds. They will shine trillion times brighter than our Sun. Then they will vanish. In August 2017, two neutron stars collided. It happened about 130 million years ago. Remember, during this time, dinosaurs were living on Earth. Part of the two dead stars collided. The explosion rattled space-time and sent waves of light across the universe. Light from the collision is bright pinpriced and then disappeared as a glow of red amber in galaxy NGC 4993. Ripple traumatized space-time, in other words, squeezed and stretched the L-shaped arms of LIGO and Virgo gravitational wave detectors. After detecting the waves, and 2 seconds later, the NASA's Fermi Space Telescope detected a gamma ray burst. When LIGO detected the chirp within 2 seconds, NASA astronomers pointed the telescope before the precious light faded away. The first to observe was Scope Telescope from Chile. They saw radio emissions from the fireball. Even the Hubble Space Telescope was turned its mirror at NGC 4993 galaxy within hours to detect the radio emission. Astronomers believe two massive stars were orbiting each other. The largest star ran out of fuel and went supernova and collapsed into a neutron star. The neutron star, our densest object in the universe, spins at a tremendous speed and generating strong magnetic currents and waves. The intense gravity of neutron star started to steal gas from its sister star, pulling the aging star, and neutron star started to swirl inside the massive star. As a result, the second star eventually died by a supernova and became the second neutron star. Then the two neutron stars started to swirl around at a top speed and shedding gravitational energy and creating ripples around it, spiraling closer and closer and finally merging, which creates a kilonova. The swirling gases bombarded with atoms and neutrons creates gold, platinum, plutonium, potassium, and many other heavy atoms. Therefore, now you know if you are wearing gold in your finger or diamond rings, these are all from a death of a neutron star. Neutron stars are visible matter, so any collision between two can be heard as well as also can be seen within few seconds. A fun fact here: a tablespoon of neutron star will weigh more than Mount Everest. This was the first gravitational wave astronomers heard and also saw, as this is truly an astrophysical ecstasy. Ever since LIGO made the first detection of gravitational waves in 2015, the observatories have racked up an impressive resume, detecting roughly 67 mergers of black holes, neutron stars, and black holes merging with neutron stars. It's amazing. If you haven't subscribed yet, please do so. Please check the bell icon for when I post a new video. Like, share, and comment below. I will see you in the next video. Cheers.